So before starting, I want to make this misconception clear, that equation of tangent is not equals to dy upon dx. Now you might say, sir, what are you saying? Because tangent, what does tangent mean? Tangent means dy upon dx, right? And that was the equation, that was a function of with respect to x. But you are saying equation of tangent is not equals to dy upon dx. The important point to note here is equation of tangent at a point. Okay, so what do I mean by this? Let's come to this graph. So here this is my tangent, okay, at point x equals to x1. So tangent at point x equals to x1. So I will write few things right now. What is my slope? Slope is dy upon dx, which can be also written as f dash of x. Now slope equals to dy upon dx equals to f dash of x. Now can I write this something else? Can I write this as value? This is valid for all x. Now if my x is equals to x1, so what is the value of my slope exactly at this point? So value of my slope exactly at this point, mt equals to f dash of x1. I'm just putting x equals to x1, and this will be my value of slope exactly equals to this point. Okay, so what is the interesting point is that this is a line, and what I am interested in is the equation of this line. So I am interested in equation of this line. I will write here and what is the equation of this slope? Here this is a function of x, right? So here my slope is something else, so equation of line will be something else. Here slope is something else and equation line will change. Here slope is something else and equation of line will also change. Slope is going like this, so equation line is also changing. But what I am interested in is that the equation of this particular line at this particular point. Okay, so what information do I have for a point, for a line? Like to get an equation of a line, what information do I need? I need 2 points. Right? Because a line has y equals to mx plus c. Okay, I will need the slope and I will need this constant term, right? So I have to get 2 equations to solve the 2 unknowns. So this m, right, y equals to mx plus c, m I already know because this is the slope of this line. Okay, so I already know the slope. I only need to find the c. How will I find the c? You will find the c just by putting this point, because this line has to satisfy this point, because this line has to pass through this point. Okay, because there is a tangent at this point, so obviously this tangent has to satisfy the point itself. So x1 y1 should satisfy. So what I can write, that y equals to just hold on a second, mx plus c. Okay, this is the line, I'm talking about, and this is equals to, like, y1 should be equals to mt. This is also mt, actually this is also mt, because obviously it has to satisfy this slope, right? For any value of x, this should yield my y as relation like this, mt plus c, and this is mt of x1 plus c, because this also has to satisfy it. X1 and y1 has to satisfy this point. I can directly visually see that this line is passing through this point P, x1 comma y1. So now I can derive my answer. Okay, I can derive my answer. What will be my answer? So my answer will be, if I subtract 1 and 2. So this is, let's name this as 1, let's name this as 2. Subtracting 1 and 2, y minus y1 equals to, I can take mt as common, x minus x1 0. So this is my relation, right? This is my relation. Okay, now what is my equation? So from here I will be able to write that y is equals to mt into x minus x1. Wait, hold on a second. mt into x minus y1 minus mt into x1. So here this is my c and this is my m basically. So this is my equation of the tangent. So this is my equation of tangent. This is my equation of tangent. Okay, so other thing that I can write directly is okay, let me just put this over a box. So from here what I can write is that y like mt, like generally we use this format that mt will be equals to, because mt we will already find out, that's why I write like this, mt equals to y minus y1 divided by x minus x1. Okay, we use this format also. Okay, same thing, just I put x1 here. So you either way you can use this formula, you can use this formula like this or like this. Okay, next what do we do? Next we have to find the equation of normal. What is the relationship between normal and this tangent? So if I just do one thing, this p1 x1 I can combine here, and normal will be perpendicular to my tangent. Normal will be perpendicular to my tangent. So it will be something like this. Okay, this is my normal. Now if normal is perpendicular to my tangent, there is a proof, I won't prove it right now. The multiplication of slopes of normal and tangent will be -1. Okay, this is a very important thing, you have to remember this. Okay, no matter what, because this may be handy in some other question also. Okay, so multiplication of slope of normal and tangent are -1 is like slope of normal at point x1. Now like again we'll use the same thing. Okay, so again I will use the same thing. So my mn, I won't derive right now, I will write directly that mn should be equals to y minus y1, because obviously it has to satisfy this point, because this normally also passing through this x1 y1 point, and obviously the slope is just -1 times the mt, 1 by mt. So basically my mn will be -1 by mt. X minus x1. Okay, so like this can be also written, or you can write it like this, that y equals to mn x minus x1 plus y1. You can write it like that, this also. Equation of normal. Okay, these are used for equation of normal. Now let's solve this question, and with this question we will understand this concept in more better manner. So they have told us, let the slopes of the tangent and normal to the curve at x equals to 1 1 be mt mn respectively. Then find the value of mt plus mn. So we have to find the slopes at point 1 1 of this particular equation. Now this equation is what? This equation is a implicit equation. I was trying to find example in the previous lecture, and this is an example, right, of implicit equation. So here, first point what you notice is implicit equation. So we will just directly take the derivative. Implicit equation. How to find the value of the slope of tangent? Simply you find the derivative, then you put that point, and you will find the value of the slope of the tangent at point 1 comma 1. So obviously I will take the derivative on both sides. So this, if I take differentiate on both sides, this will be 3x square plus, now I have to apply the chain rule, so this will be 2y plus 2x into dy upon dx plus 3y square into dy upon dx equals to 0. Now you put that value 1 comma 1. So dy upon dx at 1 comma 1 is basically my mt. So dy upon dx at 1 comma 1 is basically my mt. So what will be my mt equals to? So I can put 1 comma 1 in this equation, and dy by dx I can replace with mt. So what if I put 1 in place of x, this will be 3 into 1 square. This will be 2 times 1 plus 2 times 1 into mt. D upon dx is mt plus 3 times 1 square into mt equals to 0. So this will be 5 mt, and minus 5 is going over there. So mt will be simply equals to minus 1. Okay, mt is equals to minus 1. Then what will be my mn? Mn is simply what we know, mn times mt equals to minus 1. So mn will be simply equals to 1. So my mn plus mt will be simply equals to 0. So my answer will be 0 for this question. Okay, so because it is minus 1 and it is 1, so answer will be 0 for this question. Okay, so yeah, that is how you solve this is basic question only. Let's now find let's now solve another question, that is find the points on the curve y equals to eta at which tangent is parallel to x-axis. Now this is very interesting question, just focus on this. So find the points where the curve has tangent that is parallel to x-axis. So what do you mean by parallel to x-axis? When is my tangent parallel to x-axis? So let me draw a basic graph, okay, of sin x. Can you tell me when is my tangent parallel to x-axis? At these points my tangent is parallel to x-axis. And what does happen over here? What is the so special thing about this? Here my tangent was decreasing, now it became 0. Then again my tangent is increasing in the opposite direction, negative direction. Again here my tangent is decreasing, again my tangent is increasing. So at these points, when it is parallel to x-axis, the tangent is, the value of the slope of the tangent is 0. The slope of the tangent is 0. Okay, so we have to find the points where my slope of the tangent is 0. So that is what this question is asking us to find. So you have to decode the language. So what I will do, I will put dy upon dx equals to 3x square minus 27, and I have to equate it to 0. So I will equate it to 0. So x square equals to 27 by 3, which is 9. So x will be equals to not just 3, minus 3 also, plus minus 3. So x equals to plus minus 3, my slope of the tangent will be parallel to x-axis. Okay, will be 0. My slope of the tangent will be 0, and hence it will be parallel to the x-axis. Okay, so this was a very elegant question, like just two-liner, right? But you have to understand the language, that is very important. Let's now solve another question. We have to find the equation of the tangent and normal to the curve y equals to b raised to power x by a at the point where it crosses y-axis. So we have to find the equation of the tangent and normal where this curve crosses the y-axis. They have given us the curve, and at this point we have to find the equation of tangent. Also find where tangent and normal crosses the x-axis. Where does it cross the x-axis? Like this tangent and normal, where does it cross the x-axis? That point I have to find. Just hold on a second. Okay, so basically what you will do, here what you will do, right? So first of all, we have to obviously find the equation of tangent, and we have to know where we have to find the tangent. So they have told us where it crosses the y-axis. It crosses the y-axis here when my x is 0. So I'll put my x is 0 and I'll find the value of y. Okay, so at y-axis, obviously x should be 0. X equal to 0. So y is equals to b raised to power e raised to power minus 0. So y equals to simply b. Okay, because e raised to power minus 0 is 1. So this is the first thing, y equals to b. So the point that we have to find our tangent, equation of tangent and normal is 0 minus b. Okay, so basically what you can do, that you can write, okay, so how to find the tangent? So what is my MT? MT is f dash of what, x. What is x? X is 0. F dash of 0. Okay, so what is, first of all we have to find f dash of x. What is f dash of x? If I want to find f dash of x, what is it? F dash of x is simply b into e raised to minus x upon a into obviously minus 1 upon a, which is equals to minus b upon a, e raised to power minus x upon a. Okay, so this is what my f dash of x is. Now if I put f like x equal to 0, I will get minus b upon a. I will get minus b upon a. Okay, if I get minus b upon a, what does this mean? This means that I can equate this with y minus y1. What is y1? y1 is b x minus x1. x1 is 0. So my y will be equals to minus b upon a into x plus b. Yeah, let me turn off the voice. This sound may irritate you. Just hold on a second. Yeah. Now, okay. Now let's find the equation of normal. So normal will just be the inverse negative of this. So mn will be the inverse negative, which is a upon b. Negative of negative is positive. So this is a upon b. So now next, what next? So a upon b is equals to y minus y1. Again, this is b. Okay, this has to also satisfy the points, and x minus x1, x minus 0. So y equals to a by b x plus b. Okay, so these are the equations of tangent and normal. So this is the part 1. This is the part 1. Let's solve the part 2. Let's solve the part. So part 2, find the points where tangent and normal crosses the x-axis. So where will it cross the x-axis? It will cross the x-axis when my what? When my y is 0. So here I have tangent, right? Don't get confused with this curve. This curve is different. I'm talking about the tangent. I'm talking about the equation of this line, not about the curve. And this curve is crossing the x-axis somewhere, right? This and this curve is crossing the x-axis at x equals to infinity. That should be cleared by you. So here y should be equals to 0. Okay, so if y is 0, then I will put the first equation y as 0. So 0 equals to minus b upon ax plus b. So x equals to a is the point, and what is y? What is y is equal y should be obviously equals to 0. So this is the point where my equation of tangent crosses the x axis. So wait, right? Now what about another equation? Again I will put y equals to 0. If I put y equals to 0, then what will happen? This will be, again, if I put y equals to 0 over here, x will be equals to minus b square upon a, right? This will be 0 and this b will come over here and this will be b square upon a minus b square upon a. So yeah, this will be minus b square upon a. So my point will be minus b square upon a comma 0. So this will be something like this. So this is the equation of normal passing the x-axis. So as it crosses the x-axis, what does this means? Like can we see this visually? So here this is my tangent, right? And yes, it is cutting the x-axis somewhere in the positive because a upon b, a and b both are positive. We assume that. Now because like equation will be something like this only when a and b are positive. Now if I just draw the equation of normal will be something like this, normal to the tangent, and I can directly observe that yes, it is cutting the x-axis somewhere negative. So my answers are correct only. Okay, so you can cross check visually also. So this is the solution of this question. Let's come to the next topic, that is the equation of tangent and normal from external point. So up until now we have been finding the tangent from here, right? Tangent from here. So what will happen now is that they will give us some external point, okay, and with the help of that external point we will find the equation of tangent, and the tangent should pass this curve at x2 y2. What do I mean by this? So like let's understand this in brief manner. So they have told you some external point p, right, x1 y1, which doesn't pass through this curve, okay, and they have told you that this will be like this point will also be a point at a line, at equation of line, which is a tangent to my curve. They have told us that. Now if it is a tangent to that curve, obviously the tangent has to touch the curve also at one point, and that point is q x2 y2, okay, and that point is q x2 y2, and you may have to find the x2 y2 or you may have to find the equation of tangent. All these things you may have to find. So how to solve those we will understand. So slowly let me derive everything and we'll quickly recap also this thing. So my y is equals to f of x, okay, y is equals to f of x, that we know, and they've given you this, like they told you that we have a tangent, okay, and so what will be the slope of the tangent? Mt will be equals to dy upon dx, and for some reason we know that tangent will pass through this point q, okay, but we don't know where, so what we'll do, we'll assume that tangent passes through this curve at x equals to alpha, x equals to alpha. X equal to alpha, assume x equal to alpha, you assume, okay, so this will be my f dash of x. So now what I can say is that this will be my f dash of alpha, okay, because obviously if it is x equals to a, then y equals to f of alpha, okay, we already know this relationship, so we can say I have got my 2 points, okay, got my point, that is alpha and f of alpha, okay, so this is my x2. I'm trying to reduce the number of unknowns. I just took one unknown. x2 y2 was 2 unknowns, now I took one unknown. I'm trying to reduce the number of unknowns, okay. So now we're engineers, right? We do back calculation, so we are able to find this f dash of alpha, okay, and from here can we write the equation of tangent? So f dash of alpha equals to mt equals to y minus y1. What is y1? y1 is f of alpha. We have just derived this here, okay. This is not y1 actually, sorry, yeah, this is y1 only, this equation of tangent has slope this empty, and obviously this has to pass through that alpha and f of alpha point. So this will be f of alpha and x minus alpha, right? Yeah, sorry for the interruption. So here what I want to say is this is an equation of a straight line, right? Now this is this point x2 y2. I just reduced my number of unknowns. Now what I want to do next is that I have this point also. So this equation of tangent, this is the equation of tangent, right? This equation of tangent should also pass through P, because that is told in the question. They have told me that I have an external point P where some tangent, equation of tangent passes through of this curve. Okay, that is the wording of the question. So they have told me. So I can again rewrite this equation in a different manner. So instead of y and x, I can replace y and x in this P format. So this will be y1 minus f of alpha divided by x1 minus alpha should also be equals to f dash of alpha. So what we do is we try to find out our alpha from here. Okay, so this is the second equation, this is the first equation. Okay, obviously we'll solve question from there, we'll understand this better. So you find alpha from here. Okay, then you put this value of alpha here and you will be able to find the equation of tangent. Okay, you will be able to find the equation of tangent. That is exactly what we'll do. Now same thing for equation of normal as well. So I have given this external point, but it will be a bit different this time. Okay, a bit different this time. So I have been given this normal. Okay, this normal, and they have told me that I have an external point that passes through this normal. Now if this is the normal and I will try to find the slope of this normal, then this relation will still follow. Mn mt equals to -1. So what I am more interested in is that my mt will be -1 by mn. That's it. Everything is done right now. Everything is done. So my what is my mt? Mt is f dash of alpha. If you remember correctly, mt is f dash of alpha. So I can write my mn like this. Mn equals to -1 by f dash of alpha. So my mn is -1 by f dash of alpha. So if my mn is -1 by f dash of alpha, what I can write? I can write again. Two equations I can write. 1 by f dash of alpha minus equals to y minus f of alpha divided by x minus alpha, because again this x2 and y2 are same points, so they will pass through this point and they will satisfy this equation. Okay, and what is another equation? Another equation is this minus, this is the first equation, and the second equation -1 by f dash of alpha equals to this y1 minus f of alpha divided by x1 minus alpha. So like this is the equation, right? This is the equation. Okay, this is the second equation, and from here again find alpha, because everything is known. This y1 x1 is known, this f dash of alpha will be in terms of alpha, this will be in terms of alpha, only one unknown variable. So we will find alpha and put the value of alpha, put value of alpha in equation 1, right? Put value of alpha in equation 1. Okay, so this is how you solve this step question. Let's do one question and from there we will understand this better. Find equation of tangent drawn to the curve from origin. Okay, they are not talking about anything, they are talking about from origin what will be the equation of the tangent. If I draw a equation of tangent, so what does this mean? So I have, let's say, this x minus 1, right? So the graph will look something like this. xy x equals to 1 is y0, Okay, when is x0, it is minus 1 cube. So minus 1 cube is minus 1. So okay, when is y0, when this is minus 1 cube, when is okay, x equals to 1, my y is 0, fine. Okay, and when x is 0, when x is 0, my y is minus 1, fine. So like this is just a rough diagram. So this point is 1 comma 0. Okay, and this is, let me draw this better. This will be x minus 1 whole cube. Okay, so okay, let me just, so this point is 1 comma 0, this is x minus 1 whole cube. So the thing is, what they are asking us to find is from the origin. If I have point in the origin, now what slope will pass through this? Okay, any slope, this slope can pass, this slope can pass, okay, any slope, this slope can pass, right? So what is that equation of that slope that passes through this origin? That is what this question is asking us. Find the equation of tangent drawn to the curve, from origin. From origin, what will be the equation of the curve? Okay, what will be the equation of the tangent? That is more important. So my external point is p 0 comma 0. Okay, this is how you can derive also. You don't need to remember anything, you can derive also. And q, I don't know. Q, what point does this tangent touch this graph? What point? I don't know. So I will name them variables. One is alpha, and what will be the another one? Another one will be y coordinate will be alpha minus 1 cube. Okay, alpha minus 1 cube. It has to satisfy this, right? So now we can solve. So what we'll do, we know that my f dash of alpha, f dash of what is f dash of x? F dash of x is 3x minus 1 whole square. Okay, that is my f dash of s, which should be, f dash of alpha should be equals to, should satisfy this point, y minus this f of alpha divided by x minus alpha. Obviously it has to satisfy the point itself, right? It has to satisfy the point itself, alpha f of alpha. Okay, that point it has to satisfy. So I can further rewrite this, 3 into x minus 1 whole square equals to y minus f of alpha. So what is f of alpha? F of alpha is alpha minus 1 whole cube and x minus alpha. So this is one equation. And what is second equation? Second equation is my f dash of alpha should also be equals to not y, y1 minus f of alpha divided by x1 minus alpha. So here in this case, my f dash of alpha, so my f dash of alpha is, I just put x equals to alpha, this will be 3 alpha minus 1 whole, so this is not x actually, sorry, this will be alpha, right? This will be alpha equals to y1. What is y1? Y1 is simply what is y1? What is y1? Y1 they have given, right? Origin. Y1 is origin. So 0 minus f of alpha is alpha minus 1 whole cube divided by, again, x1 is 0 minus alpha. So you will solve this. So what will happen? Alpha square and like we are assuming alpha is not equals to 1. Okay, if alpha is not equals to 1, we can simply compute alpha is not equals to 1, and what is happening over here? So this is minus minus gets cancelled. This is alpha minus 1 equals to, this alpha goes over there, 3 alpha. Okay, we're assuming that alpha is not equals to 1, right? So yeah, or okay, what you can do, okay, what we can do, if you want to assume alpha equals to 1, okay, this is the best thing. So this will be alpha minus 1 whole cube equals to 3 alpha into alpha minus 1 whole square, and you can take alpha square as common. So this will be alpha minus 1 minus 3 alpha equals to 0. So alpha can be equals to either 1 or minus 1 by 2. So because if I further simplify this, so this is how you solve, right? When something is multiplied by 0, so this will be am I doing anything wrong? What went wrong here? This is minus 3. Yeah, minus 3 alpha. Correct only, right? Yeah, this is minus half of it. Okay, so this is minus 2 alpha minus 1 equals to 0. Okay, so obviously I can see that either my alpha can be 1, either my alpha can be minus half. Okay, so we have to check whether this satisfies. For alpha equals to 1, alpha equals to minus half, we have to check. Okay, this may happen, the two tangents may pass through the origin. Okay, two tangents may pass through the origin, we have to check. So for alpha equals to 1, for alpha equals to 1, so this will be, what will this first equation become? So this is my first equation. This will be 0. Okay, and this will be y minus 0 by x minus 0. So yeah, alpha, alpha is 1 only, so this is x minus 1. So y equals to 0 is what we are getting. Now is this possible? Y equals to 0. Y equals to 0 means that, this means y is equals to 0 here, right? That means this is the x-axis. This is the x-axis, and yes, it does pass through this origin, this tangent. Okay, because at this point, right, at this point my slope will be 0. I hope you know, because if you put x equals to 1, you will get slope as 0. Slope will be 0, and that is correct. That this is the x-axis. So this is the x-axis, which is true. My diagram is not that good. I hope you understand the cubic function very well. So true. Okay, next is alpha equals to half. Okay, so what does my f dash of alpha becomes? F dash of alpha, if I put minus alpha, this will be 3 into minus 3 by 2 whole square equals to y minus minus 3 by 2 whole cube divided by x minus alpha. So this will be x minus alpha, which will be x plus half. Okay, so now if I further solve this, what will happen? This is 3 into 9 by 4, 3 into 9 by 4, which is 27 by 4 into x plus alpha, which is x plus 1 by 2 equals plus, now this is cube, right? So this will be minus 27 by 8, and minus will become plus, and again this will come in this side, so this will be minus again. So minus 27 by 8 will be equals to y. So if I expand this, what will happen? If I expand this, this will be 27 by 8 plus 27 by 8 minus 27 by 8. So y will be equals to 27 by 4 into x. That will get cancelled out. Okay, so this also passes through the origin. So when my x is negative, y is also negative. So if I am lying around here, my x is negative, y is also negative, and this obviously passes around the origin. So yeah, it is correct, right? This slope is correct. Okay, when my x is negative, y is negative. When my x is positive, y is positive, and obviously the x intercept is 0. Okay, so this will be the answer to this question. Like, I will have two equations. So I should write find equations. Of tangent drawn to curve this, okay, from the origin. So this is the answer to this question. Let's solve another question. The line x plus y equals to 2 is a tangent to the curve. They have given us the tangent of the curve, this, at its point alpha beta is, okay. So they have already given me the line of the tangent, and they have given me the curve. They are asking at what point is this tangent to, now is this simple? I think you can use shortcut. What is the shortcut? Shortcut is basically check options, right? Check options. Obviously, if this point is a tangent, then this should satisfy this equation and this equation also. So this is the line of the tangent, so obviously it has to satisfy this equation. The tangent has to satisfy this equation at that particular point, and it has to also satisfy the equation of the curve, because tangent touches the curve, so it also has to satisfy the equation of the curve. So here what I can write is that satisfy equations. Okay, so here if I write like x equals to 3, if I put here x equals to 3, then what does y become? Y becomes -1. So yeah, this satisfies the first equation. So let us satisfy the second equation. X equals to 3, this is 9, minus 3, 6, divided by 2 is minus 2, which is not correct. This should be -1. So first one is not satisfying. What about second one? X equals to 1, y equals to 1 is 2, fine. X equals to 1, y equals to 1, this is x equals to 1, this plus 2, it becomes 3. Yeah, this is satisfying. So like this option will be the correct answer. You can just solve it in seconds. Okay, and these two, right, you can put this in equation, it will not satisfy. Okay, so obviously you got to the answer, and in the examination hall you will choose this method, but right now we're studying the concept, so obviously we'll use the concept as well. So my x plus y equals to 2 is the equation of the tangent. X plus y plus 2 is the equation of tangent. Can I find my empty slope? So if I rearrange this equation in the standard line equation format, this will be minus x plus 2. So obviously this -1 represents my slope. Okay, slope of the tangent. Empty will be equals to -1. And what is this equals to? This is equals to simply y minus f of alpha divided by x minus alpha. What is f of alpha? F of alpha is this, right? So basically I can write what is my y equals to. So f of x will be equals to, if I take this side and take this side, this will be 3 minus x squared divided by 2. 3 minus x squared divided by 2. Okay, so this is 3 minus x squared divided by 2. So now what does this happen? So here this is -1, this is y minus 3 minus alpha square divided by 2 divided by x minus simply alpha. This is the equation. This is the point where it touches the curve. Alpha and f of alpha are the points where it touches the curve. So here what I can write this like this, that y equals to minus of x minus alpha plus 3 minus alpha square divided by 2. Now I can further rearrange this. Y equals to minus x plus alpha plus 3 minus alpha square divided by 2. So alpha plus 3 minus alpha square divided by 2 equals to what? They have already given me this equation, standard equation. So I will write like this is -1, and here I am getting -x. This is satisfying. Now I just try to replace this with 2. Okay, they have given me the y x intercept, right? X intercept. Okay, when my x is equals to 0, this should be equals to 2. From here we can easily find the value of alpha. We can multiply 2 on both sides. This will be 2 alpha. 3 minus alpha square equals to 4. So alpha square minus 2 alpha plus 1 equals to 0. So alpha minus 1 whole square equals to 0. So alpha equals to 1. Okay, is a point. So if alpha equals to 1 is a point, what I can say? I can directly put that, right? I can directly put that alpha equals to 1. So alpha is equals to 1, and what is beta equals to? So beta will be simply f of alpha, which is equals to, I can put x equals to 1 in this equation. Okay, so like f of alpha is here, right? F of x is here. That is 3 minus alpha square divided by 2, which is 3 minus 1 divided by 2, which is equals to 1. Okay, so x y equals to alpha comma beta 1 comma 1. Very simple, like nothing, not much brain you have to use. Okay, pretty simple. The answer will be B. Okay, so this is how you try to solve this question. Okay, so I hope you got the concept of equation of tangent. This is not very important, but you don't have to remember a few things. You can also derive right? You can also always derive. Okay, I told you from derivation also, like I'm solving this from the basics only, so you can derive and solve this question. In the next lecture we'll study monotonicity and maxima minima. These two topics are very very important. You have to keep your full attention. Okay, in this lecture also, if you like watch it in 2x, that's fine, because equation tangent may come, okay, but not that important. But it is important, obviously all the topics are important. If you want to be a topper, right, you have to study all the topics. Okay, that is first thing. But the importance of those topics are higher than this one. So I will meet you in the next lecture with a new topic. Thank you for watching.